Now we are going to talk about the displacement can be positive or negative. As you remember, we discussed about the formula delta x equal x final minus x initial. Result of this can be positive or negative. It can be positive or negative, and the meaning of positive and negative gives information to us about its direction. What does it mean? If you consider the number line, at the center we have 0, at the right side we have positive numbers, at the left side we have negative numbers. And here, if the result is positive, that means the movement of the object is in the positive direction. If you find the result negative, so it gives us information the movement of the object into negative direction. Now here there are 3 different pictures. First one, second one, and the third one. We're gonna do calculation on them. You will see the result and we will discuss about them. Let's erase this part now. Let's keep the formula there and erase this part. I need place. Okay, let's erase formula 2. I will rewrite it again. Let's choose the pen. Yes, let's talk about the first one. The first one, initial position is the 10, final position is the 80. Now I will not care about the unit, centimeter or meter, just focus on the result. The result gonna be positive or negative. So as you see, all the movement in the right direction. So according to me, what I said to you, the result of them should be positive. And let's see, it will be positive or not. And delta x equal x final minus x initial. What is the x final and x initial here? Here x initial is the 10 and x final is the 80. So 80 minus x initial, which is 10. So the result is 70. This is the result, which is 70. And 70 means, what does it mean? It is positive 70. So the positive means it's moving to the right. If we consider the number line, so it is on the right. So it is correct, we can say. And let's talk about the second picture. I will use same formula again. Delta x equal x final minus x initial. What is the final point? 12. Minus, what is the initial point? 3. So 12 minus 3, it is the 9. So 9 means it is positive 9. It means it's moving in the right direction. Is it moving in the right direction? Yes, it is. And let's talk about the third one. Delta x equal x final minus x initial. And now my final position is positive 6 minus my initial point is, as you see, negative, you can zoom on it, negative 10 minus negative 10. So negative and negative gonna make each other positive. So it will be 6 plus 10. So result gonna be 16. That 16 means positive 16. So if the result positive, it moves in the right direction. Is it? Yes, it is. So my result is correct. Again, I can say to you. Now we're gonna discuss about displacement can be negative. In the previous part, we discussed about displacement positive. Now all the displacement negative. Why? To the initial point and the final point. So it is moving. The arrow shows the direction. It's moving in the negative direction, and the first picture, second picture, negative direction, third picture, negative direction again. I will support this information with the formula. What is the formula of the displacement? Delta x equal x final minus x initial. Now, x initial is 80. Now it moves from 80, point of the 80, to point of the 20. So this is the initial position and this is the final position. So final now it is 20 because it moves from 80 to 20 minus from the formula x initial. X initial is the 80. So result will be 20 minus 80. It's gonna be negative 60. So that negative indicates to us it moves in the negative direction. Is it? Yes, it is. And now second one, delta x equal x final minus x initial. Here it moves from 15 to 0. So final position is the 0 minus initial position is the 15. So result will be negative 15. So the negative result means it moves in the negative direction. Is it? Yes, it is. And the third one, I'll rewrite formula delta x equal x final minus x initial. So writing formula every single step of the solution is very useful. It can protect you to make any kind of mistake. Here, as you look at it, I will zoom it. It moves from negative 10 to negative 20. So it moves from here to here. That means it's moving in the negative direction and in the negative side. The other first and the second picture, it was moving in the positive side into negative direction. The result becomes negative. Now it's moving in the negative direction and the negative side. So what's the final position? The final position is negative 20 minus, according to formula, initial position negative 10. So it will be negative 20. That negative and negative makes each other positive. So it will be positive 10. Negative 20 plus 10, it is negative 10. So result is negative. It gives us information. It moves into negative direction. Is it moves in the negative direction? Yes, it is. So here we have to understand displacement can be positive or negative. That positive give us information about its direction and that negative give us information about its direction too. And the magnitude, that means number, give us information how much it displaced. Okay, that is important. Keep it in your mind. So the number has got meaning and the sign of the number, either positive or negative, has. Yes guys, in this simulation we will talk about the displacement, and displacement can be positive or negative. We will focus on the displacement. So as you know, displacement is change in position. Now position of this guy at first it is at 0 meters. Now the guy, if it moves in the right direction, that means positive direction, let's say to 6, his position now 6. That means the guy walk in the right direction 6 meters. Our displacement is 6 meters. And if the guy return back to 2, let's say, now initial position is 6. Final position is 2. This is the final position. Roughly, let's say it is 2. So we can make it 2 also, but we can look at it roughly, no problem. So let's accept it is exactly 2. So initial position 6 and the final position 2. What is the displacement here? Final minus initial That means 2 minus 6, it will be negative 4 because the guy moves in the negative direction. If the guy moves from 2 to negative 2, let's say the value, yes, negative 2. Now our final point is the negative 2. Initial point is the 2. So the result of the displacement will be what? Minus 2 minus positive 2. So it will be negative 4. So in this case, our displacement will be negative 4. That's all about the displacement, we can say. Meaning. Now we are going to talk about the velocity. What is the velocity? Any moving object covers displacement in a time intervals. That is important here. It is written displacement, not a distance. So this is very unique point. Keep this in your mind. It can be useful in your examinations. So here, when the time is 0, the car standing at the point of the 10 meter. After 1 second, it covers 10 meter. After the first second, to reach second second, it covers 10 meter again. So at the initial point, it was at the 10. After 1 second, it reached the 20 meter. After 1 second, it reached 30 meter. Actually, velocity gives us information about displacement and the time, we can say, and also direction. That direction part we are going to study also. So here we have a formula. That formula is the formula of the velocity. And velocity equal delta x over delta t. Delta x is what? Displacement. Delta t is the time. Unit of the displacement is meter. Unit of the time is second. So unit of velocity is meter per second. Keep this one in your mind. It can be useful. Now I'm going to talk about the average velocity. Average velocity, total displacement divided by time interval during which the displacement occurred. It looks like very similar as the velocity because it's the average velocity. But what does it mean? I will simply talk about it. If you are driving from city of the A to city of the B, and while you are driving, when you are in the car, of course the way and the path, the road is not always straight first. The second, velocity of the car is not always constant, isn't it? So when you start your motion, the velocity of the car is 0. And when it starts moving, it reaches 50, 100, 80, 90, 70. It will change on the way. And finally, when you are going to stop, it will be 0 again. So on the way, the velocity always change. So if you take a long way, long path, every instant time, every single moment, maybe your velocity is changing. Sometimes you are applying brakes, sometimes you are applying gas. So due to this, according to this, the velocity of your car changing. Because of that, on the long ways, we are taking the average velocity. For example, you moved from city of the A to city of the B. We can discuss about the average velocity. We have formula. That formula very similar as the formula of the velocity. Displacement over time taken. Displacement is the delta x. Time taken is the delta t. So average velocity formula, V average, delta x, x final minus x initial over t final minus t initial. That is the delta t. So this is the formula of the V average velocity. This is final position, this is the initial position, and this is final time, and this is the initial time, we can say. So this is the average velocity. And the unit of the average velocity is same as the velocity. It's again meter per second. Now, there is one question, one simple problem about it in your book. I'm gonna solve it now. During the race on the level ground, Serdar runs with an average velocity of 6.02 meter to the east. So to the east means it's moving only in east direction. This is important. What distance does Serdar cover in 137 seconds? So when you read question, it's asking what distance. So here it's asking what is the displacement, actually we can say. So the question is what is the delta x? And then after I have to check the givens. Here it's written average velocity. V average is 6.02 meter per second. Is there any other given? Yes, it is the time. Delta t is 137 seconds. So what was the formula? V average equal delta x over delta t. So question is what? What is the delta x? Let's change the color of the marker. So from the cross multiplication, I can send the delta t here. Delta x gonna be V average multiplied by the delta t. So V average is given 6.02 times, or we can put the also unit meter per second multiplied by 137 seconds, which is delta t. Second and second cancel each other. We have only meter. Then what is the unit of delta x, which is displacement or distance unit? It is the meter. So when we multiply 6.02 times 137, delta x gonna be 825 meter to the east. This direction is also important. Here it doesn't give us positive side or negative side. It gave us, the question gave us directly to the exact direction to the east. And east direction is, as you expect, it is the positive side of the direction, we can say. Practice 1A. You can find these questions from your book. Now I'm gonna solve some of them. I hope you are gonna understand them. Good luck. Now I'm going to solve this question. Question says that Haiwa walked eastward with a speed of 0.98 meter per second. If it takes him 34 minutes to walk to the store, how far has she walked? The question asked to us how far has she walked. It means it's asking x. And in the question we have given speed, which is v, and we have time, which is given 34 minutes. And formula about this, v equal x over t. And here question says calculate the x. So due to formula x equal v times t. Speed times time. Speed given 0.98 meter per second, and the time given 34 minutes. But I have to convert time into second because here it's given meter per second, so time must be in second. So to convert it to second, I have to multiply time with the 60, so it's gonna be 2040 seconds. And now let's continue from here with the formula x equal v times t. And now I'm going to substitute them. V equal 0.98 meter per second times time equal 2040 seconds. And second goes, we have meter as a unit, and it must be meter. 0.98 times 2040 can be 1999.2. Thanks for listening. This question says that it takes you 9.5 minutes to walk with an average velocity of 1.2 meter per second to the north from the bus stop to the museum entrance. What is your displacement? In this question, it's asking delta x, and if we write the givens, v average equal 1.2 meter per second, and the time given 9.5 minutes. First step, we have to write the formula v average equal delta x over delta t, and the question asking what is delta x, so delta x equal from cross multiplication v average times delta t. And the second step, v average is given 12.5 meter per second, and delta t given 9.5 minutes. So now I have to convert time into second, so it is equal 570 seconds, and into third step it will be substitution. Delta x equal v average times delta t. V average 12.5 meters per second times delta t is equal 570 seconds. Delta x gonna be 7,125 meters. Thanks for listening. In this question it says Aram drives his car with an average velocity 48 km per hour. So we have average velocity to the east. How long will it take him to drive 144 km straight away? In this question it says how long. How long means it's asking time. In the first step, let's write the givens. We have V average, which is equal 48 km per hour, and we have delta x, which is 144 km, and the question says how long. That means what is the delta t. In the second step, I'm going to write the formula of V average. V average equal delta x over delta t. And the question says find the delta t. So I will send the delta t here, and the V average instead of delta t due to cross multiplication. So delta t gonna be delta x over V average, and the unit of the V average kilometer per hour, and unit of the delta x kilometer. So I will not convert anything. I will do in the third step only substitution. Delta t equal delta x over V average, and the delta x 144 over V average 48. So it's gonna be 3 hours. Thanks for listening. In this question, it says bus travels 280 80 km south, straight path, average velocity of 88 km per hour. And the bus stopped for 24 minutes, then it traveled 210 km to the south again, and with the average velocity of 75 km per hour. And at the A, it's asking how long does the total trip last. That means it's asking what is the delta t, and it's at the B, it's asking what's the average velocity of the total trip. So B, I have to calculate V average. And let's solve the firstly A. I have three-way here, three part. The one part, it moves 208 kilometers with the average speed of 88 kilometers per hour, and it stopped 24 minutes. Then it goes in the same direction 210 kilometers with the 75 kilometers per hour. And here for each part I will calculate the time. For each part I will calculate the time t2 and t3. Then I will add them to each other to find final answer. First, the formula of V average, it's equal delta x over delta t. I will apply this formula for T1 and T3 because T2 is given directly. So delta t equal delta x over V average. So T1 equal delta x over V average. Delta x for the first period 280, and V average is 88, 3.18 hour. And T2 gonna be delta x over V average again, and the delta x in the third period 210 over 75, 2.8 hours. This is the T1 and T2. Here delta t equal T1 plus T2 plus T3, and the T2 is the 24 minute. 24 minute means 0.4 hour. So delta t gonna be T1, which is 3.18 plus T2 0.4 plus T3 2.8 hour. So finally T gonna be 6.38 hours. Now I'm gonna solve the B. At the B, it's asking what is average velocity. V average equal delta x over delta t. Now I'm going to substitute given V average. All the total way is sum of the 280 plus 210, and the delta t as we calculate 6.38. So V average gonna be 76.80 kilometers per hour. Thanks for listening.